Okay, welcome to the next episode of Math Talk. Let me make sure I'm not spiking the microphone. And it's a special episode because today I'm joined by my good friend, recently minted, as of a couple hours ago, Dr. Mishty Ray.
Okay, hello.
So maybe just to start things off, do you want to say a brief couple words about what the vague topic of your thesis is?
Yes, I guess I've already had some practice this morning to describe my area of research. But yeah, so my area of research is the Langlands program, specifically the local Langlands program. It studies the relationship between objects coming from harmonic analysis with objects coming from number theory. And a very brief way of thinking about the objects is like it studies symmetries between these two areas. And my thesis is about looking at this kind of correspondence from a geometric perspective. Is that
excellent?
Right?
Yeah, perfect. And so, let's start at the beginning of how you actually got there. How did you first get interested in mathematics, or when did you even realize that you were interested in mathematics? Like, did you start from a very young age? Did you ever do any math competitions, or did it take a while for you to figure out that's what you wanted to do? Or
yeah, like I was not interested in mathematics when I was in school. In fact, it was one of the, I was okay at it. It seemed like a bunch of recipes to compute things, and it was sometimes very satisfying to compute the volume of some object or using calculus, but it wasn't very interesting to me, and I frankly didn't know much about it. But then I went to university, and there I took a few math classes in the first couple of years when you're just trying to figure out your area of research. And I was really surprised by how beautiful the proofs are and how elegant mathematics can be, how it's not about the computation, but why does it really work. And so that kind of piqued my interest, and then I opted for a math major. And even then I was working a lot in the applied side of things, but as my degree progressed, I started getting more and more curious about pure mathematics, and that's why I decided to go to grad school and do some pure math. Yeah.
So by the end of your undergrad, I think I remember you saying you have some experience somehow doing some machine learning and some class field theory. Were those both experiences you had in your undergrad?
Not the machine learning bit, because at the time that wasn't a fad.
Right. Yeah.
But I wrote a paper on numerical methods, technical words are data assimilation and chaos theory, and it's about like predicting what happens in dynamical systems, and that involved a lot of dealing with numerical data. But at the same time, I had a choice of who to do my master's thesis project with, because it was an integrated degree, so we got a master's at the end. And I chose specifically a person who did pure mathematics and number theory, and he kind of told me to read about class field theory at the time. So I guess I did both at the same time, and the machine learning was later as a summer project thing.
Right. So then you decided to pursue pure mathematics for your PhD. How did that begin? How did that go about? How did you end up deciding where to go? Or, normally people just apply a bunch of places.
Yeah, that's what I did.
Right.
Yeah, it was kind of random. I was really carefree at the time. I thought, this looks interesting. I want to learn more. Let us apply to grad school. So it was kind of a random decision. That I sort of made by myself, and I applied. A lot of my peers were applying to PhDs as well, so I was in that sort of environment.
So you did it because all the cool kids were doing it.
Yeah, exactly.
You're pressured into
school. Yes. So it wasn't a very well thought out kind of plan. I just sort of went with the flow of whatever I liked at the time. So I just randomly decided to do it. That's how I make all my decisions. So
I wonder if this area has a way of just attracting attracting that kind of mentality precisely because it's kind of broad in some sense. And so it's like, well, if you don't have strong convictions, then you'll end up in something that draws on a lot of different things.
It's definitely possible. I never thought about it this way, but I definitely, my gateway drug is definitely like learning some number theory.
Right.
And that led to it. Yeah.
So then, okay, so you didn't necessarily have a clear idea exactly of what you wanted to do.
I had no idea.
Coming into grad school. So then how did those things sort of shape and take form over the course of your grad school experience? I mean, of course, you have an advisor, and your advisor guides you towards some particular topic, typically. But how did these things evolve for you?
Yeah, I mean, initially I was told to read, like, because I had read some local class field theory, I sort of approached the professors who were most closely working with things of that flavor, and I was just told to read Tate's thesis, which is a brilliant thesis written by this mathematician by the name of John Tate in the 1950s, I think, maybe 1950. And that essentially establishes a very base case of this whole Langlands program business that we're doing. And so I read that. And then, of course, from there, technical details again, it's GL1 case of Langlands. So from there, you read about GL2. And then there was a lot of reading involved for a long time. And then, I guess it was a very linear path. Like the things that I was told to read were natural things you would read if you were trying to get into the Langlands program. Again, I did not know that that's what I was trying to do, but
Right.
I was just like, I know this, now what? Give me some guidance. Yeah. So that's what happened.
And then ultimately you landed on Vogan's conjecture for GLN.
Yeah, so in my conversation with my advisor, Clifton Cunningham, here at Calgary, he was very good at figuring out what question I should have for my thesis work, because I think he very carefully read all the kinds of things I had in my background, and he decided maybe this is going to be a good project for me. And he proposed it, and I sat with it for a while, because he told me to think about whether I want to do it. And then a few weeks after he told me about the project, I decided, that this sounds actually very reasonable, and it makes a lot of sense that he suggested this project. So that's how I ended up doing my PhD thesis. Vogan's conjecture is the title of my PhD thesis. So I did the problem because my advisor gave me that. I was like, thank you, professor. I shall do as you say. Yeah.
Well, now it's time to leave the nest, so to speak. And so the content of your thesis was you resolved Vogan's conjecture for GLN.
Yes.
Which is sort of the fundamental case to check things for.
Yeah.
And so now, moving forward, you're going to be, working towards presumably generalizing this to other groups. That's sort of be the main thing.
Yeah, that would be a main theme of my research going forward. But it would be an interesting challenge to think about how I can branch out from what I have done in my thesis to find my own path in research. So both things side by side, but definitely this is something I will pursue. It's natural to pursue with collaborators.
Yeah, I guess just thinking about it now, it's probably a useful thing to sort of have one main thing that you can always return to, and then pick up bits of knowledge as you cycle around some other postdoc positions or something.
Right.
Slowly branch out to there, and every time you get maybe stuck or dismayed with these other things, you've got this central problem to reconnect with.
Yeah, hopefully. Like, it's like, I don't know who said this, maybe Atia, like how when you first learn mathematics, you learn a little bit of your area, and then you go out in concentric circles. Like you then learn a little bit surrounding that area, and then you learn a little bit surrounding that area. and that's how you broaden your perspective. I also like how this mathematician by the name of Korsher Berger, I think, he's a Fields medalist, and he said that when I was a beginner in mathematics, it was like walking around the beautiful city of Cambridge, I think, and looking at all the buildings from the ground. And then later on in the career, it feels like you have sprouted wings and you're flying and you have an overview of how these buildings connect to each other. So I like that idea. I like that way of thinking about it. Yeah.
Yeah, I think sometimes maybe I've tried to fly a bit too early. I'm excited to see the bird's eye view, and it's like, and then I realize I start climbing up the building. I'm like, I don't have wings yet.
Yeah. Oh, yeah.
Check out these streets a bit more.
I get that feeling. Yeah. Yeah.
So, and now, speaking of having, picking up knowledge from other places, you have a couple postdocs lined up.
Yes.
So, how did those come about? Like, how did you meet, the people? How did you find about these particular postdocs? How did that whole process work for you?
Yeah. So I already knew about the people in the area who were working in our area, related areas, specifically in Canada. So they were natural. Like applying for a position with them was a very natural thing to do. So that is something I definitely kept in mind. Like apply to all the places where I know who's there and who's working on what already, as opposed to like just searching for jobs on a place where there's a list of jobs, which you should also do. I should apply everywhere. I applied everywhere that had a position for postdocs. But I started my list with the people I already knew and kind of wanted to work with. And it was natural to want to talk to them after talking to my advisor and doing what I did. And some of those things worked out. Yeah, I also reached out to them and I said, hey, I applied for a job. Please consider me. So I also did that.
So I guess looking at things now from the tail end, having extremely recently finished the journey. Well, there's probably like last minute edits, whatever.
It's done. I'm never
it's
opening
done.
my
It's done again.
No, I have to do it. Yeah.
But with that in mind, I guess, are there maybe key pieces of advice you might give to any of our viewers watching who are maybe thinking of doing a PhD or maybe in the thick of it, maybe words of inspiration or words of caution, things that you learned along the way about the process itself?
Yeah, I would say that at this time, if you're thinking about doing a PhD in pure math, think very carefully about the job prospects after that. Of course, I don't want to be completely cynical and say you should only do a PhD because it's such and such a job lined up afterwards or something. I mean, if it's pure mathematics, the jobs in academia are difficult to get. So think about what you would like to do, even though it is sad to do that. After masters, probably want to continue in your university because it's a safe space or it's a comfort zone for you to be a student and keep learning things. But I would say think about the job prospects. So that would be before you decide to apply for a PhD. And when you apply for a PhD and you're choosing advisors, something to keep in mind is whether you have the possibility of having a concrete problem to work on. Whether the advisors you're consulting with, they are really listening. And one of the biggest quality of a good advisor, which I was lucky to have, is that my advisor listened to me. So, sometimes grad students don't know anything. There's no point listening to them. I don't know anything, but it's so important for that listening to happen so that you're giving somebody a problem to solve, and you might want to be aware of their strengths and weaknesses. So having a concrete direction and somebody who can offer you a concrete direction in grad school is very important because it's a long journey. You can get lost. You can just fall into the grad student trap that I fell into also, of just reading and nothing coming out of it, and gaining a lot of scholarship scholarship, which is very, very nice if you're interested. But having a clear path is very important. And that is something that it would be a very good idea to work on in collaboration with your advisor. And then sticking to it. So that is something academic. And I would also say try to have some hobbies so you don't burn out. I mean, it's kind of a thing everyone says, but I feel like it's really important.
Right.
Yeah.
Right. Yeah. I definitely do. Well, as you know, I have a habit of getting distracted by shiny things. So somehow I overhear someone in the office say something interesting. Something like completely unrelated that I should not be thinking. Well, were you gonna?
I was just gonna say try to have hobbies, but don't have too many hobbies.
So that's also that is a pitfall I had earlier on. I think I was involved in too many student politics things as well. Whatever, some sort of club. Oh, you need someone to volunteer for that, and then eventually the third year rolls around. Oh, maybe I should write it.
Good timeline.
So one question I've augmented one of my questions. I used to come at this from an angle of your disposition of mathematics as fictionalist versus realist, sort of like do you believe in a Platonic proof of math, or do you believe in that it's just sort of a language game that we make up? But I think the way I'm trying to ask this now is maybe your view in the doing of mathematics. So another thing that you know already is I'm kind of uptight sometimes about very particular details when you're not in certain places. And I've sort of come to this realization lately talking with people online that some people are much more laissez-faire, speaking of the word you mentioned. And then it's
being so sassy.
But there are people who really have a strong belief that actually the details of proof aren't so important. What is more important is the ideas. And I've sort of slowly started to accept how I can interact with these people mathematically. So where do you fall anywhere on those divides? Sorry about preemptive.
I mean, it's actually, maybe this will come as a surprise to you, but I sort of understand the issues you have about details and there not being enough details and things sometimes, and who is the paper really serving if you're writing a paper with things which are not clear. But I would fall on the side of moderation, to be honest. Like, there's always a push and pull when you're doing research, how deep do you want to go, or whether you want to keep your eyes on the prize and finish the thing that you're trying to prove. So if you are trying to prove a theorem, then prove the theorem. But like if there's something that follows from previous work where maybe the details are not clear, it is a very difficult thing to decide whether you want to reprove that or whether you want to leave it aside or what you want to do. So I would always advocate for moderation and like knowing very well what your work is trying to do. Is your work trying to establish some of the fundamentals of the theory, or is your work trying to use some of the existing tools to write a result? And of course, it's not a binary all the time. But I would say, on the side of moderation, ask the experts what they think. I would say also that helps. Like, is it something acceptable to assume something that you think is not clear in the literature? You can ask experts and they can tell you you can't really do that, or they can tell you, it's a folklore theorem. And then if you really are interested in it, you can set that aside for later to investigate. So knowing the purpose of your work is kind of important, but it's very hard and it takes a while to learn how to navigate that. I'm not even sure I know yet how to do that fully. So
I think that's something that's come up even in some of these math talk episodes recently a few times, is the sociological nature of things. And so there's learning the proofs and techniques that are written in the books. Then there's also learning this sort of extra communally accepted theories as well. That's sort of this extra,
and then finding a reference for the communally accepted things. Yeah, and if you're a younger researcher, then it's intimidating to challenge, the experts. Like, oh, where is it written though? Like, it's difficult.
Right.
Yeah.
So, I think that's great. Great advice, balanced advice. I mean, moderation seems to always be the answer with just about anything.
Answers are going to be the most boring, generic, average things you can think of, maybe.
Well, but I think, I think those often end up being the true answers. At least for different things I've found in my life, I've gone to extremes on one end of something and the other, and then you sort of explore both ends, and you're like, yeah, okay, I guess it is just sort of like,
Yeah.
somewhere the answer's kind of mushy in the middle.
Yeah, but it's hard. I understand your frustration.
Do you have any final parting words of advice or wisdom for any mathematicians at home or future mathematicians, wherever the people might fall in that spectrum?
Build a good community around yourself, and that takes a lot of initiative, and sometimes it's not afforded to us, but if you can build a mathematical community, build that and go to conferences, talk to people, stay in touch. And even if you are not so social, it's good to have a support system, either mathematical or social. If you don't see a lot of women around, like if you're in an underrepresented community, then it can be very challenging. Your imposter syndrome can be more intense. So I guess building a community of people that you look up to and who inspire you is so important. Like when I first came to this department, I went around, found every single woman I could, forced them to be friends with me. And that really made a huge impact in my quality of life as a grad student. Although I would say I'm very lucky to have an amazing research group. Don't get too flattered.
I already, my head's not going to fit out the door. I'm going to camp out in the office for the night.
But I feel like I'm very lucky, but not everyone gets so lucky. But build a community. Talk even with professors, and talk to the professors in your department, and talk to professors you meet outside. And it really, really makes you feel like you're part of the mathematical community, as opposed to being a grad student, which can be really challenging.
Well, I think those are some wonderful words to leave off on. So thanks again for joining me, and thanks again for being part of this journey together. We started at the same time in fall 21.
Yeah,
so
we did.
Quite the journey.
Yeah, it's very fun. Yeah.
All right. Well, thanks everyone.